Hi there, welcome to the video on adding and subtracting integers, right, and positive and negative numbers. So, just so that we all understand what we're talking about, integers include all the positive numbers and negative numbers out there in the world, including zero, but no decimals, technically, right? So, only whole numbers. That means no decimals. They are technically not what we call integers. So examples of that would be, well, it includes zeros, so zeros in there, 16, 23, -4, -10. You notice that there's no fractions, no decimals. We often use integer chips or circles to represent these positive and negative numbers. When you're working in a textbook, right, sometimes positive are red, negative are blue. You'll have to kind of look at the legend to see which is which. +4, when you're writing in your notes and your homework, though, easiest way to show that is just because you probably don't have colored pens with you, is to do 4 circles with positives in them, and then -5 would look like 5 circles with negatives in them. So those are our integer chips, and we'll play around with those in class a bit. They're really, 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 really helpful when you're doing addition questions with positive and negative numbers. So I'll show you what I mean here. So I got a word problem right off the start. Says if there is a temperature increase from 8 degrees, sorry, if there's a temperature increase of 8 degrees, starting from a temperature of -3, what's the temperature now? So we've got a bunch of circles. We started at -3. So these three are the -3 degrees that we started with. And then we're going to increase that +8. So we have 6, 7, 8 positives. And we want to know what the temperature is now. So integer chips are really helpful because what happens is that when you line these positive and negatives up, they cancel, right? So it's kind of like you take one step forward, one step back. Haven't gone anywhere, right? You're kind of at zero. So after you cancel whatever you can, whatever you're left with, that's the answer. So here we have 1, 2, 3, 4, 5. So the answer would be +5 degrees, right? It is the temperature now. So you can see how they're super handy. Here, it's just a little blurb about what these zero pairs are. So when you're adding integer chips, right, a zero pair is a pair of chips where one chip is a +1 and one is a -1. +1 and -1, right, together, that's a zero pair. So there are 6 questions here that want you to draw integer chips, right, or draw positive and negative circles to answer the following questions. As you get better and better with this, you'll obviously stop having to draw the pictures. But for these 6, it's a good habit just to do right now. So I'll help you with the first 2 and then leave the rest to you. So +7 would be 1, 2, 3, 4, 5, 6, 7. And then I'm going to add to that -4. Looks like this. When I cancel out all these zero pairs, whatever I'm left with is the answer. 1, 2, 3. The answer to this is +3. Okay, so why don't you try the next ones all on your own. D, you can see that it's a negative and negative, so there won't be any canceling. There's no zero pairs there. Same thing with C. So give it a go. Pause the video. When you're done, unpause it, and I'll try the last question with you. All right, welcome back. All right, let's try that one last word question here with the adding before we move on. It says, suppose the temperature change from 5 degrees to -15 occurred over a 4-hour period. How could you determine the temperature change per hour? So let's do this with integer chips. We started out like that, and then -15. Super cool, right? 1, 2, 3, 4, 5. And I think that's my 15. So after I do all my zero pairs, cancel, 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 I'm left with negative 10 degrees Celsius. Pretty cool. Now, we haven't answered the question though exactly. They want to know how would you figure out what is your temperature change per hour? So this happened in 4 hours, right? We went from positive 5 to negative 15. Now, that's a difference of like, from 5 to negative 15, 20 degrees. But if I were to look at a number line, 1, 2, 3, 4, 5, positive 5, and all the way down to negative 15, I have to jump 20 times to get from 5 to 15. So the current temperature is negative 10, but I've actually changed Celsius over 4 hours. So 20 divided by 4 is 5 degrees per hour. So that's the answer to your question. So make sure you're reading the questions carefully. They can get kind of tricky. All right. Why don't you turn the page over and let's talk about subtraction. So subtraction, in my opinion, is a little bit trickier. I also think integer chips are the best tool here, right? Although here it says integer subtractions can be modeled using integer chips or number lines. For me, I think it's easier with a number line, but I'll show you both. So here's our subtraction question. 5 minus negative 3. Okay, so this question, actually, let's make that a positive. Okay, 5 minus positive 3. So you could draw 1, 2, 3, 4, 5 chips, and then if I'm going to take away 3 of them, right, you're left with 2. This is a pretty straightforward question that you probably saw, back in kindergarten, grade 1, wherever it is that you learn. So that's not too tricky. It gets tricky though when there are the negatives in here. If you were to represent that on a number line, you find the first number on your number line, and then subtract means to go left, right? So if we're subtracting, we're moving left. We're going to move left 3. 1, 2, 3. And no big surprise there. You landed on positive 2. Okay, so it gets a little bit trickier, but remember, subtract means left. There's one exception, right? When you subtract a negative number. So that's a negative number. It does not matter what the first number is. This rule is only for subtracting a negative number. So it says when you subtract a negative number, it's like adding a positive. It's the double negative rule. So for example, I'm not going to do my homework means you're totally going to do your homework. So in a question like this, you would rewrite it. The first number you're not going to change. But rather than subtracting negative 2, it's like adding a positive 2. And if we put brackets on here just to keep it clear, right, essentially it's just saying 6 plus 2, which we all know is 8. So I'll show you a couple again on the number line, and that lets you finish the rest on your own. Positive 7, right? So I go to the number line, find positive 7. Subtract means to go left. 1, 2, 3. I land on my positive 4. Now the first one in here is a negative 3, but it's the same idea. I'm going to find that negative 3. Subtract means to go left, right? I'm getting smaller, right? Left is smaller. And I'm going to subtract 5. 1, 2, 3, 4, 5. The answer to this question is negative 8. Okay, so do the rest yourself. Right? Watch out for those minus, 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 minus. Right? You'll have to rewrite the question as 2 plus 2. Same thing, right, with F and E. Okay, pause the video. Good luck. And I'll join you in a second for the last question. All right, welcome back. So, order of operations, putting all these things together. From the order of operations, we use that handy little name trick thing called BEDMAS, which stands for brackets, exponents, division, multiplication, addition, and subtraction. Now, what that tells us is the order that we have to do these particular tasks in when we do a question traveling left to right. Now, the only trick is that addition and subtraction, if you saw subtraction first, you do subtraction first, even though addition, like the A comes before the S. Same thing with the division and multiplication. See, multiplying before division is multiplying, right? Another way we could write this, I guess, would be to say them de that, right? The order of those ones don't matter. It's just whatever you see first, left to right. So we'll do the example together and the rest will be yours. When you do these questions, for full communication marks, it's really important to work down, right? So it's not a left to right thing, it's an up and down thing, right? In math, right, we write vertically, not horizontally. I'll practice, show you what a really good form looks like, and then hopefully you can do the same. So, B, brackets. Let's do those brackets first, all right? So I'm going to write bed math right here so I can keep track. So I'm going to leave everything the same until I hit the bracket. -3 minus 2. Okay, I'm just going to off on the side. There's two little steps of my number line. 1, 2, 3. There's -3, -6, -8. -3 starts here. Subtract means to go to the left. 1, 2. Right, my answer is -6. So in the bracket, I can simplify that as -6, and then everything else is the same until I'm ready to move on to the next one. Okay, if I see an exponent, I'm supposed to do that next. So I'll keep everything the same for now. And 3, or 2 to the exponent 3, remember, isn't 6. It's not 2 times 3. It tells you how many times you're going to multiply that base number of 2 by itself. So 2 times 2, I know that that's 8 times 2. So 2 to the exponent 3 is actually 16. So that's going to be -16. Oh, wait. No, it's not. Because let's get that mistake. Let's try that again. Uh-oh. 2 times 2 is not 8. 2 times 2 is definitely 4 times 2. I was kind of thinking ahead of myself in my head. So there's your -8. Okay, so now I've taken care of that. I can do the division. 8 divided by 4 is 2, plus -6 minus 8. And, okay, and now if we're going to do this in the order it appears, 2 plus -6 is -4. So feel free to draw some integer chips to help you with that. 1, 2, 3, 4, 5, 6. You can see the -4. And then -8, right? A number line would work really, really well. Start at the -4. You're going left 8, gives you all the way to -12. So I hope that's helpful. Why don't you try A, B, and C on your own, and then we'll go over the questions next day in class. Thank you.